Okay. Welcome at Software Circus. Hope I'm not blocking you from the screen. This is early August edition. Sorry for the delay. We had to postpone it for 2 weeks because of the heat wave in the Netherlands. I hope you enjoyed it anyway. The heat wave. And what we have for you today, or coming up next, is HashiCorp in September. In October, we have super awesome big event with Sam Newman. You can still sign up for it, I think.
Is it going to be here or?
No, it's going to be an external venue.
Yeah, it's going to be a lot.
It's going to be huge.
Bigger than normal meetup.
Yes.
It's already 150 people signed up. Okay. So it's not limited, so you can still wait for it, but you better sign up soon if you want to do it.
Yeah, because we're going to close soon.
It's also an interesting topic. So it's not going to be all just about technology. It's like a mix of technology and people. So it's very interesting.
Yeah. And we are hiring, of course. You can grab a link or QR code, wherever you want.
What does it lead to?
Yeah, don't scan the code. This leads to 0-day exploit.
0-day IIS exploits. I think my phone crashed.
Yeah. So, welcome to the stage Andreas and Alex with their Knative. Applause.
So, let's have some fun.
Thanks for the introduction and welcome everyone. It's really great to see new faces and familiar faces as well. And we will talk about Kubernetes native CI/CD and the tooling that's currently exists to support that, and tooling we explored. There is certainly more, but this is the ones we concentrated on. And it will become obvious what the title means from and to as the talk continues. My name is Aleksandr. I work for Container Solutions. I'm cloud native engineer. I'm helping clients to migrate their stack to cloud platforms. Also, we're doing cultural renewal as well to support that migration.
Yeah, and good afternoon also from my side. My name is Andreas Krivas. I also work with Container Solutions as cloud native engineer. And yeah, I'm from Greece, and well, I like to tell people that Kubernetes is a Greek word, which it is, and that most of people say it wrong.
Can I pronounce it right? I think I know.
Give it a go.
Kubernetes.
Close enough. It's Kubernetes.
Kubernetes.
Yeah, which means governor or a captain of a ship, right? So.
You should put a transliteration next time.
Kubernetes. Yeah, phonetics. Right. So, but now you know. No excuse next time. I want to hear it correctly. So, before going into what is Knative, what it can bring us, or why is it interesting for us, and maybe for you, one thing I want to ask you all is to name one thing that you like about Kubernetes. As a developer, or as operations, or as a manager, doesn't really matter. One thing that you like about Kubernetes the most.
It pays the bills.
Sorry?
It pays the bills.
Pays the bills.
Pays the bills. Everyone's bills are just everyone else.
My bills.
Okay.
You must be a manager.
Nice. All right.
Anything else apart from financial stability? That's it.
Documentation?
That's pretty good, yeah. I think my favorite is tooling. I really love kubectl and auto-completion. I think this is amazing. I think this is really sets the standard for interacting with the software from CLI.
Yeah, and at least my personal favorite is declarative way of treating objects, right? So it's just amazing that you can just declare something and deploy something, and then Kubernetes takes care that it's running exactly how you want it. It will not allow any changes to it unless you want it to. So that solves a lot of pains when you work with Kubernetes, right? So of course there are a lot more things why we like Kubernetes, but what is even more interesting, I think, is what we don't like about Kubernetes. Because of course it's not like unicorns and rainbows and stuff like that, right? Upgrades. Okay? Yeah, that could be a pain. And maybe vulnerabilities like a couple days ago. Yeah?
Lack of security by default.
agreed. So by default, Kubernetes is open as as you can think of. That's a good one.
Every file system is read and write.
Yeah,
by
right.
default.
That's a good one, indeed.
Is there a login?
Sorry?
Logging.
Login?
Log in.
Into the infrastructure.
Or in Kubernetes.
Kubernetes, yeah.
Not really. I mean, you can
But
have
you can
like
run it
servers
anywhere, right?
and even online. So
Yeah, but once you set up your Kubernetes, can you move away quickly?
To another Kubernetes class.
Yeah, I think it's interesting you bring this up because I think lock-in, it's not even only in Kubernetes, but if you use Kubernetes on, say, AWS platform, it comes with its own very specific integration points as well, and then can you even migrate one Kubernetes to another Kubernetes platform quickly enough, right? So
Yeah.
I think there's certainly a lot of complexity built in there that's
Yeah, even if you look at cloud providers, they are different, right? ECS with the GKE and KS, and they're different. And or even if you take a consideration OpenShift even, which is even more different.
Yeah.
So yeah,
even though they're all Kubernetes, right?
Yeah.
So
Yeah.
one Kubernetes is not equal to another.
But also what we also see in clients, one of the things that companies struggle, especially if they are new to this technology, is how do I learn it? How do I untangle all the complexities of Kubernetes if I'm just a developer that just want to deploy my code in an environment, right? Because you need to know deployments and secrets and persistent storage and ingresses and services. It is a bit more complicated, right? And that's a nice picture that I like to use in talks and presentations, that on one side shows how the cloud native landscape is at the moment with different technologies and different tools. You see Kubernetes as a port, still some Ansible in place, that's quite true. And yeah, containers being managed by Kubernetes. But at the same time, it depicts very well how complex is the landscape at the moment. How complex is cloud native, especially for new adopters, right?
Yeah, and also I think I really like this comic as well. I think it really illustrates also all the technology that support Kubernetes and how much you have to really know in advance before you can even start grasping as to what Kubernetes is and what it does.
Yeah, exactly. And a lot of, let's say, engineers, one of them is Joe Beda, principal engineer of VMware, and for those that know Heptio, he is the co-founder. He said that quote, basically, that engineers, we tend to create very complex things, and we tend to forget that they are equally complex for people to learn and adopt them, right? And that brings sometimes steep learning curves for people and companies. And that's why we're starting to think with Alex, all right, it should be a better way. It should be a way to make that easier for developers to deploy code and streamline the adoption of Kubernetes.
But is there?
Is there? Yeah, that's still a question actually. One tool that we try to explore to see if that actually solves our purpose is Knative, right? And from a certain perspective, especially from CI/CD perspective.
Yeah. And I think what you said is a good point, that vendor lock-in is definitely a dangerous side effect, but also I think the positive is really big, that everything is converging into a single platform that becomes almost like an operating system in that traditional sense. And we explored specifically CI/CD aspect of that, because for CI/CD you always kind of have to use some third-party build system where you integrate your secrets, your all your build steps, and then that feeds back into your deployment production clusters.
Yeah. So Knative as a first step. What is Knative? Knative is a middleware basically platform developed by Google 1 year ago, almost to the day. It was his first birthday a couple of weeks ago. Along with other companies like Red Hat, IBM, Pivotal, they did a lot of work with Knative, and SAP. And it runs on top of Kubernetes. It's not a replacement. It's not Kubernetes. It's just more enhanced. You still need a Kubernetes layer, and then Knative deploys on top of that. Really briefly, these are the three main components of Knative. The first one is, start with the middle actually, the build component, which is basically building your application into a container image natively on Kubernetes. So not another environment that Docker runs saying you need also to maintain. It builds it in the same cluster that it also runs. Then we have a serving component, which is basically takes care that your application, once it's a service or let's say it's live, gets traffic in and out. takes care to scale it from 0 to 1000, and basically, arranges all the routing of the application.
And the third one, yeah.
And the third one is eventing, which is the key component, one of the key components and differentiators of Knative. It's about event-based architecture and workloads. So that component takes care when there's a new request coming in to alert the respective service to spin up a new pod, for example.
And what I wanted to say is that even though these components are entirely independent from each other, but they're definitely there to support functionality of each other. And we'll see that from build and serve during the demo.
Yeah. You have a question?
So in short circles.
Yeah. So the two main. So why Knative? Summing it up, two main reasons. First, building container images natively and easily with no residues and leftovers and no environments to manage on the same Kubernetes clusters that they're running. And secondly, bridging the gap between Kubernetes and serverless applications. Suppose, what I showed before, all these three components, you can think of it simply that an application gets built, gets served in a Kubernetes cluster, then if there's no traffic going in, Knative will stop it. 0 pods running, nothing in a cluster. And once an event gets in or traffic starts coming in, Knative will take care to scale it accordingly. If it needs to scale to 1000 from 0, it will take care to do that. So the promise here from Knative is that it will bridge the gap between application and serverless and provide a better way to create container images. Still, some high-level resources for Knative so that we reference it later because we have 2 demos for you guys, so it's going to be a bit more technical. First, we have the first part, Knative build, like we discussed. It's good to remember that we always use a build template, which is basically a definition of the build process. As you can think of it as your Jenkins file or your GitLab CI file, basically what actually want to build and how it gets built. We have a build resource, which is an instance of that build template that you pass maybe certain arguments that are specific for that build. And then we move over to the serving side, which is a bit different than the Kubernetes service that probably most of us are already aware. The Knative service is basically the container or the pod that is created after the build is complete. It's not just a service that exposes a pod, it's the pod itself and encapsulates a route, which is the way that the application will get traffic, right? Just a basic route, and a configuration, which is specific configuration to make the service live. And those two create a revision. So you can have a configuration that says, I want to deploy blue-green or a canary. That will take a service, which is already there. The configuration will create a revision that will route 80% of traffic, for example. So you can have multiple configurations, you can have multiple revisions, and multiple routes, and that's one Knative service. Simply, as we can say, simply put. That's important to know because later on we'll mention Knative service, and it's good to remember that it's always a configuration, a route, which creates a revision at the end.
So it's slightly different from Kubernetes service.
Yes. So, first demo. We wanted to show how this end-to-end workflow works at the moment in Knative. So we thought of creating a demo using GCP and GKE cluster. The reasons are just because GKE is very good. And the flow we created is we have a repo in our GitHub. We push a certain tag, then a trigger gets activated in Google Cloud Build that will start some Knative build in our cluster. You see here the word Canico. Canico, is anyone aware of Canico? That's great. So Canico is used to build our image inside a pod. It builds a container image inside a pod, and then when it's done, it spins down, we move and actually ships the image to our container registry.
Just to point out that Canico runs entirely in the user space, so it doesn't need Docker socket or Docker daemon or privileged rights to elevated privileges to run. It builds entirely in the user space.
Yeah, so not Docker needed, nothing needed. Very clean, very simple, and actually very fast, as you will also see in a few minutes. And then Knative serving component pulls that image, deploys a service, and then makes it ready to receive traffic. Now, it's a simple workflow. What we will show is also a bit the YAMLs, right? So how you can create that, how you can deploy such a demo. Before going to the YAML, so that you don't have to look in the YAML and try to find interesting fields, this is kind of a breakdown of the YAML itself that we're going to show. We have one single manifest, nothing else, one single manifest of Knative service, and with two main configurations. The build one, which has some requirements like a service account, of course, the Git source of the code so that they can get the code, the build template that I mentioned before, so what kind of build process do we want to use, and then some arguments that depend on that build only. And that's an image name, the builder image, which is Canico in this case, it can be something else, in our case it's Canico, and path to Docker file in the context. And that's the only thing you need. And then there is a simple revision template. So like Alex mentioned, we really focused on the build component, so the service and revision stuff are very simple and very default. You can do a lot of things with that, so you'll see that this is very simple at the moment, just what images we pull and maybe some environment variables we want to push. So, time to check if the demo works.
One thing I wanted to mention as well is that we're using a very limited subset of Google Cloud Build. It basically just receives requests from GitHub with the new tag, and then it triggers the build in the Knative.
Yeah. So
even though Google Cloud Build can do a lot more stuff and build things, but we use it only to trigger the build.
Yeah. So before I trigger, actually I will trigger it, and it will take less than 2 minutes to finish. So git tag, give one. I'm just pushing a tag. You can also do it with branches. Just for demo purposes, we did it with tag. Now, just to show you quickly that the trigger is getting activated, this is our Google Cloud Console, and here is our trigger, which was activated and fetches the code, and it will apply the YAML that I'll show you now. It will apply this YAML. So this is, if you see at the top, I'll guide you through that. We have a Knative service YAML, some normal metadata, and then we have our build configuration, which has a service account, the source of the code, then what template we are using, and then these 4 arguments: the image, the builder, the path, and the context. And that's it. And at the end we have the revision template, which image to pull, hello from the other side, just a message, dummy message, and that's pretty much the only thing that is needed to kick off a build, create an image, push the image, pull the image, and deploy to Knative. So let's check what's happening. Build. So I have also a CLI tool, which is for Knative. It was developed by a Pivotal or Cloud Foundry employee. It's still 0.3 version, so it's still being developed, but it's good enough for now to show us some logs. Now we see that already the build has started, taking some snapshot of the file system, and soon it will start showing all the Docker file steps, and at the end it will push. It will take about 1 minute and 80 seconds, so we have a bit more time for questions maybe at this point.
And just one more thing I would like to mention is that even though we're using Knative CLI tool and for Tecton CD as well, but you don't have to use any of that. You can still inspect resources in Kubernetes with the kubectl the same way you do inspect deployments and other built-in resources. It's basically just CRDs, and the rest is Kubernetes native, which I think really hits that point.
Yeah. Any questions so far about? Yeah.
So when you're talking about routes and canaries, so what makes it possible under the hood to implement canary? Like is it some smart proxy or Cube proxy or certified equal stuff, or what does it?
So underneath that creates Kubernetes ingress resources. So it's basically just ingress that allows that.
Okay.
And then Kubernetes manages as any other ingress.
And you can use any type of ingress or?
Yeah, so in our case we're using Istio, for example, and we're using Istio as a service mesh. You could use anything you want. you can still also configure it with your own configuration, but there's not a lot of granularity yet. Still, the route are usually created automatically by Knative. You can't really choose yet what kind of route it is. But underneath, it's just ingress in Kubernetes.
But what if you run it on AWS? Will it create a load balancer, only one or one per service?
So I mean, yeah, like, is there any requirement to ingress control itself, or can I use, let's say, GCE controller, which is pretty stupid, slow, and buggy? Like, will it work with?
I think it should be pluggable,
Yeah.
but I don't know for sure. I don't know if you have experience with that.
Yeah, in this case, for example, in GCP, I think it will just create an external load balancer and will open it to the internet, and that's it, right? And as long as Kubernetes has the rights, or GKE has the rights to do that, then you're fine. Knative just uses the same thing.
I think it's actually, it creates a global load balancer when you initialize Knative, and then after that, when you deploy something like that, it actually updates the Istio rules to route it through that global load balancer that you already have, and then internally it hands off with Istio.
Yeah, if you have Istio, right? I mean, Istio, also now if you go to install Knative with that tool, it will install automatically Istio with it, so it gets packaged with both. It's not necessary to use Istio, but indeed, in most cases, you will use Istio for that.
Did you install Knative here yourself on GKE, or did you just create a GKE cluster with the Knative check?
We just installed it ourselves.
Ourselves, because same with Istio, you can still do it, still kind of beta, so it's not everything that you want there. That CLI tool is designed to apply all the CRDs that you want for both of them. And the good thing that it does also is that first applies Istio, has a loop that checks that all the pods are running, and then starts with Knative and does the same. So when it's done, you know that everything is applied correctly and it's running.
And when you check the Knative in Google Cloud, will it also install Istio?
Yes, but I actually recently heard that it's actually installing like a particular version of Istio.
Yeah.
So
Yeah.
That's not to work properly with it.
Yeah.
Exactly. So our build is done. It took 2 minutes and 48 seconds, a bit more than 2 minutes. It was built and it was pushed to our GCR and built successful, and it's done. Now, if I do service list, we have one service that's running. I can also show a bit more about that service. Show a bit more information. So now our service is deployed in the cluster, is ready to get traffic. You see configuration is ready, so the revision is already created, the routes are ready, everything is ready, and it's initialized and it can receive traffic in under 2.5 minutes with building the image natively on our cluster ourselves. So we created this demo. We said, okay, that's quite nice. It's fast, it's clean. You need a really minimum amount of YAMLs. But then we started thinking a bit ahead, right? So what if you want to test an application, or if you have a lot of microservices, you want to have really unit tests, integration tests.
That's right. And it with a Knative build and the build templates, it's really difficult and awkward to put all of these steps like you would do with the normal software development, integration tests and unit testing and so forth, and load testing. And that's how we came upon Tecton CD. It was rather accidental, because when we started looking at Knative build, there was a big warning sign on GitHub README saying a proposal to deprecate Knative build is in progress and to be replaced by Tecton CD. And I'm like, what's Tecton CD? And so Knative build was a tool that nobody will probably end up using because it's going to be deprecated by the time it will get known. And so that's what got to Tecton CD, and there is a lot of similarities. So Tecton CD is inspired by Knative build. It takes basic building blocks of Knative build, which is an execution of steps, and actually looks very, very similar to Google Cloud Builder as well. The way you define steps and Builder are simple Docker containers. And it's I think first or the second member of Continuous Delivery Foundation, so it got very wide support of community and the big businesses as well to develop that tool. And as I mentioned, there's a proposal to deprecate Knative build in favor of Tecton CD, and the reason being that Tecton CD really fleshes out the whole pipeline idea and all the consequences coming with that. So Tecton CD. it creates a bunch of custom resource definitions. Who heard of CRDs in Kubernetes context? So CRD, just for context, is a custom resource that is created by an API, and it has a controller running inside Kubernetes that when a user tries to create a resource of a certain name, so in our case, either deployment or a service, which is a built-in. In this case, say a task or a pipeline. Kubernetes will shoot that off to an internal controller of Tecton CD and saying, hey, there is a resource of named task wants to be created, and here's all the manifest details of that definition. And so Tecton CD does stuff internally to create that and maintain the lifecycle. So Tecton CD has a task resource, it has a pipeline resource, it has a pipeline resource. It has a task run and pipeline run, which is simply instances of task and pipeline respectively. So I think pipeline basically encompasses tasks, and tasks are executed in succession, and tasks pass around inputs and outputs, which are pipeline resources, which could be GitHub, Git repository, and image registry. So our demo is very similar in to the first one, except that instead of Knative build and only Knative build, we use Tecton, and we define two tasks. One will simply build Docker image from a Git repository, and the second task will be executed right after the first one, and it will deploy to Knative service. And they pass around resources to accomplish that.
Yeah.
So just in slightly more detail with pipeline run, pipeline, and task run. So task run and pipeline run are instances, and task run is created implicitly when you execute a pipeline. And the way to execute a pipeline is to describe that pipeline and create a pipeline run resource, and then Tecton controller will start executing tasks in that pipeline. So I think the pipeline resource type Git and type image are very interesting because they it really means that it's a statically typed arguments that you can pass around between tasks, which makes the pipeline creation very flexible, and implementing all the steps of your pipeline is predictable and has a lot of possibilities.
Yeah, the thing to mention here is, of course, Tecton CD can be used outside of Knative context, right? It's just bringing the pipeline mindset into Kubernetes.
So yeah, I think it's also a bit easier to grasp because it's so familiar. It's so familiar. You have a pipeline and you have tasks in the pipeline like you would do in Jenkins, for example.
Yeah, and in this case, that help us think, okay, this may be a way to create some unit tests or actually integrate tests or sanity checks in pipeline. So we encountered an interesting problem.
Yeah, I think it was really trying to mash together the sequential style of execution and declarative resources like Kubernetes provides. And an interesting thing that to rerun the same pipeline, you have to create a new instance of pipeline run. You can't simply change the existing pipeline run because it's only an instance of that. And there's a handy way to rerun a pipeline is to pass a generate name and a dash, which will create a suffix, randomly generate a suffix, and create a new resource. So you can't use apply anymore, you have to use create instead. And this is going to be, I think, levied more by events that are currently being worked on in Tecton to trigger things without manual run and intervention.
Yeah, this was interesting because when we want to create, because a pipeline run is an instance of a pipeline object, right? So you want to create or have multiple pipelines running at the same time, as probably you would also want in a CI CI tool. That was a problem because it was the same name. So it's already okay. You have actually this pipeline run ready there, so it didn't do anything. So we said, okay, how do we break this pattern? So we have multiple pipelines of the same object. We used that, but then you couldn't apply it anymore or maintain the desired state because the name always was different. So these are interesting problems that are a bit counterintuitive for Kubernetes.
Yeah, and I think if you think of a pipeline run as an instance of pipeline, then that really is just a revision of every pipeline execution.
Yeah, so in a similar way, we'll kick off the Tecton, and we'll see what are the differences.
So the way it knows how to execute either Tecton or Knative is by parsing the tag name. And if the tag starts with Tecton, it will run the Tecton pipeline. And if the tag starts with the Knative, it will execute the Knative one.
Yeah, and here is the YAML of the pipeline run. So it's even smaller. It basically requires a name. What's the pipeline reference that we have here?
And there's a bit of overhead there because we have to create those pipeline resources, like a Git repository and an image. So every step knows exactly what is passed on and how to access those attributes. And so we split definition of those resources and the actual pipeline. So it makes the project a bit neater, and also means that every microservice can include its own pipeline definition and its own tasks on how to build it within the context of a bigger application.
Yeah.
So if you point to PyCalc Git, you can see how we can define a Git repository.
Yeah. So just
every step knows that, every task knows that there is a revision field and there is a URL field, and that's all it needs to fetch the repository, apart from service account details, obviously.
Yeah. So let's see how that goes. We have a different CLI in this case. So our pipeline has started. So I just need, that's the thing, because now it's a random name at the end of the pipeline run. So same story as before. You start building the application, but the difference is what happens when it will finish, because the previous case we just were seeing one part, the build, and then we have to separate the service part, because these are not integrated, they are decoupled different components. In this case everything happens in the same pipeline, so we're now getting the logs of the complete pipeline. So you had 10 tasks, the logs for every task will show here, or like Alex said, also in the logs of the respective pods, of course, underneath.
So the deploy task will then simply execute a kubectl command and apply the new service definition for Knative, so it will kind of integrate that and replace Knative build. And you could also do that for external clusters, so if you say only build a test cluster and you build your software there, you can then run kubectl to execute commands to deploy your software on a different cluster. Yeah,
so we see the last step that we pulled the code, we pulled the image, and then the service was created. Now, if I do the same thing as before and see all the services, we have the new service which is up and running. Now, of course, you notice that there is a red service there. 1 out of 3 case. This is the first one we deployed, but that's expected. Can someone guess why? Why that's expected?
Nobody calls it, so it's down.
It's down.
Yeah.
There's nothing running. And we can verify that. Normal kubectl. So the one that we deployed at the moment is 3 out of 3 and running. The other ones, it's completed and it's done. It's 0. So if we had traffic coming in, then Knative serving will take care to scale it accordingly. Now the timeout for that I think is also configurable. The default is like a minute or so. If there's no traffic for a minute, then it breaks it down. But this is nice because then you don't have 24/7 running services if they're not used.
And I think for me it was a big, a bit of a mind shift. That I think, how do I find out whether my pipeline run was succeeded, apart from running Tecton CLI tool? And I think, wait a minute, like everything is actually a normal pod in Kubernetes, so you just inspect it the same way you would do inspect any other Kubernetes pod.
Yeah. So demos worked. That's good news. Now, wrapping up a bit, because we talked about a lot of things. Both technologies, especially Knative, as we mentioned, in Knative we just touched 1/3 of it. Just the build component, and we just used the service component to serve our per person demos. A whole new world is when you actually start to look into the serving and eventing component, when you actually start to work with serverless containers. But still, it was a good start, I think, especially for Tekton to see the pipeline mindset start to be embedded in Kubernetes in a more native way. It's not mature yet to replace your current CI/CD. It's not close to that, so but there are really promising features of it that maybe it will become more mature in the future. And again, it's
Yeah, for me, it's very interesting to see where that goes in terms of testing your software against your existing microservices. So if you deploy one version and build it, then that means that you don't have to have mocks anymore and some weird proxy sitting in between things to see if it still complies with the definition and such and the API specs. So everything is running against a single Kubernetes cluster, which is for me was really neat.
Yeah. So a few takeaways. There are more to that, but Knative, as also proclaimed by Google recently, is going to be really enhanced and evolved in the next year and even more. They really believe in it, and more companies they're going to heavily work on it.
I think that's proven by the Knative checkbox on creating Kubernetes cluster in Google Cloud. Heavily invested.
Yeah, and we were at a workshop with Google, and it was a very nice quote. The moment I heard it, that was great. Coming from a Google employee, and he said, "I'm not a religious guy, but Knative is the closest that I can get to religion." Right. So that showed that okay, there are promises about this technology. Also for us, it was something new to explore. Still, I think the versions are 0.8. We're not even in one version.
Maybe not close to religion, but cautiously optimistic.
Yeah. So we definitely want to explore more, especially the eventing and serving capabilities, but also start integrating some more tests in the pipeline and see how that will go. But for the meantime, that's all we had to share with you today. You can find the demo on our GitHub. Of course, has some prerequisites like having the GCP or QBuild and some service accounts.
I think you can't really run it on your laptop unless you have like 32 gigs of RAM.
Yeah, it's also a good
the
point.
minimum we could come up with was 16 gigabyte RAM on GCP cluster and GCP. So it's resource intensive.
It is, and especially because we also have Istio and then Knative, so both of them are a bit heavy on resources.
Maybe without Istio it would be then a lot easier.
Maybe. But yeah, and here is also the link about the deprecation proposal, which is now in discussion, and it will probably pass. So Tekton will be part of Knative ecosystem. And now it's time for questions. Thanks for your attention, and happy to answer anything you have.
So is it a single instance, the resource, the needed resources, or is it the whole core?
What do you mean, single instance or core?
The resource prerequisites.
The GKE.
Was it a single instance?
That's a single instance.
What we tried was a single node cluster. Eventually we ended up with 32 gigabytes just to have in a couple of minutes the image built. But yeah, it can be cluster as well. It's not a problem. Yeah.
Should be transparent, I think, to how many nodes you have in a single cluster or just a single node cluster. Shouldn't matter in this case.
Yeah, well, yeah. If you want to upload to real life, of course you want. It's always nice to record.
Yeah, of course. Yeah.
So what I really got from this talk is that if I want a canary, Knative is a way to go. It makes my life easier, etc. And if I don't want canary, are there any other reasons that would make me to throw away my lovely Helm chart and use Knative?
Yeah, I think eventing is another kind of dark horse that we didn't really do the double around with this, but you also can have integrated eventing systems. So if you use that, then that
What's
makes sense. Eventing system within Kubernetes. But the serve.
Yeah, so the serving is just to make it easier to open an application or create canary, which we can still do with Kubernetes to a certain degree. If you remember on the first slides, the main capability is about serverless containers. So that's where the power of Knative actually shines, because it can bring scale to 0, can trigger with an event and scale up again. So for normal applications or some more traditional applications, not sure if that would be benefit. For serverless and microservices, yeah, I can see it a bit more. It's Canary or Blue-Green, that's indeed some good things that you can do and very easily here, but it's really about scaling very quickly in and out, but still using Kubernetes underneath, not having to go to Lambda and have all this
Given that you have
complicated
16 gigabyte cluster running under the hood.
Yeah,
you
that's
get
fine.
Serverless containers.
Yeah, but that's fine, right? So they try to bridge that gap because the transition from Kubernetes to serverless seems that it's a huge jump because serverless doesn't solve everything. If you just look at functions themselves, they try to bridge the things that are missing, like how do you do service mesh and how do you do networking underneath with the Kubernetes power. Right?
Okay, and then another question: what about Canary? Like, if I want Canary in the end, as you mentioned, there are different ways to implement Canary, right? And Knative is one of them. And for example, recently I noticed something new for myself: annotations in Nginx and Grace, which allows you to do Canary.
Yeah.
Can you compare it a bit?
Yeah, again, I mean, depends really also on your application stack or your landscape, I think, in my opinion. In this way, you don't have dependency on another application, right? So the purpose of Knative is the native part. So you do it only on the Kubernetes. You don't need Nginx, you don't need Traffic, you don't need something else. But you need to maintain on top of that and upgrade and have a single source that everything comes in and out. Here it's your own cluster that actually decides on how to route things. So I think that's one benefit. And the second is, again, depends on if I had 100 microservices in a cluster, probably I would go for this one because it's easier to manage. Otherwise, having an Nginx takes care of anything. So it depends also on the use case. I don't think one is better than the other. This is specific to actually tackle the serverless scaling and the scaling problem with the serving component. So yeah, I think
so. The answer is if you're doing serverless or you want to do serverless, it's Knative. If you don't, whatever you want.
Well, yeah. I mean, if you don't, you can still use it. There's no problem, right?
But there is no big difference.
But there's no big difference.
Yeah. Okay.
I think it depends, right? Like I've been thinking about this a lot, and I'm thinking I don't know exactly how it works with like only Knative. I'm mostly comparing it to the Cloud Run thing, which I'm more used to. But with Knative, if you're as a developer, you want to build a Knative application, you have only one YAML file that you have to define, right? And you're done. Yeah. If as a developer you want to build a Kubernetes application, you have to write a deployment, you have to write a service, you have to write config maps, probably secrets, probably ingress, maybe some other things depending on what you want to do. So you have bam, 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 you need to define all that YAML. And for a generic developer who's not very into Kubernetes, that's kind of overwhelming. If you give them something like Knative and they say, okay, this is the only thing you have to define, this only YAML, Knative will handle the rest for you. That makes it much easier for development teams to get on board.
And I think that's how
and I think
they put that story forward, right? So it's a developer oriented, so you don't have to know exactly config maps and deployments and all the services and ingresses and so forth. You just define your own service and then you get asked that service.
Yes, and I think that's actually the most important message. Like, oh, that you also get Canary deployments where they get it's nice. That you also get like these different revisions and all that kind of stuff, and that you can get rollbacks. Yeah, that's nice, but the most important thing is get it simple for developers.
Yeah.
He's in sales.
Yeah, I am actually. Sorry. But really, I like it. So,
But he's entirely correct, right? So that's also our main driver behind this, to see how actually easier it is to develop and deploy an application. And it was so easy that
because neither of us really had any experience with that, so
so
we just created a YAML file and then it runs, right? And
of course, you have
the
the prerequisites, so you need to have your environment set up properly. You need to do some pre-work there, but once that's done as a developer.
Did I mention Cloud Run?
Yeah.
Okay, I'll shut up.
No worries.
Maybe I can add another advantage.
Yeah.
As we just saw that the service stopped. But we all know that developers don't stop their pipelines. They start them, they test, and then thank you. And then at the end of the week, you have to clean up all your cluster because it's running full with some things that are doing nothing. That's maybe another advantage.
I totally agree. Yeah, I think it's like 5:47, time to go. Boom. And then you have everything running and consuming resources. If it's especially resource-intensive tasks,
Yeah, and that would make a huge difference if you have a really in the hundreds of microservices, right? If half of them are not used but they're running, but if this can actually make sure that they run, that things that are running are only things that actually have some interaction, That's actually a big thing in the long run. But also for, if you deploy something, you forget about it, then you have a guard keeper here to shut it down. But yeah.
Look at your memory usage. What is this? What is this? Oh, there's all these things running. What are they doing? Oh, no. Okay, got rid of them.
Now they're not running, but they're still there.
Yeah, but they don't use the memory.
Yeah.
And why you said it's not production ready? So what is not production, or why? Or what?
I think for as far as Tecton concerned, there is still no proper ways to trigger pipeline runs except for kubectl create pipeline run. And so what they're working on currently is eventing system supporting cloud events mainly. So it's going to be a kind of single way to execute your pipelines and trigger pipeline runs and so forth. So I think that's a big missing step right now. And obviously the second one is that it's so new that there is no support model yet. So there's a lot of gotchas.
Yeah, as a whole, it might be not ready, but for example, if you say, I'm not going to use the build, or even I'm not going to try Tecton, but I have my own CI/CD system which is very mature and I go to production, you can still say, okay, Knative, take that image from one repository of that artifactory and deploy that. That should work fine. So, but as a whole, Knative as a platform is still they try to decouple. I mean, they are decoupled, but not entirely decoupled yet. The components between them, so there's still work to be done. But you can still try to use components that you can. And I think the serving component is the most mature at the moment. The eventing really depends on serverless. It's just really about serverless and event-driven applications. So that's a specific use case. And the build one is deprecated for Tecton. So still, investigating what's actually the proper setup of Knative.
Volatile.
Yeah, it's a bit volatile.
About politics. I noticed a few names on the list. So of course Google, IBM, Red Hat, let's name them. But also, I'm sorry?
It's one company.
Exactly, that's what I'm saying. But there's a few missing. Microsoft is not mentioned. Alibaba wasn't there, and they are both.
Alibaba was there.
Oh, was there?
Yeah,
Okay, I missed that one.
Alibaba.
Okay, so it's actually only
Microsoft.
the Microsoft missing. What is? Can you maybe tell about that?
But
Yeah,
GitHub
so-
was there, right?
I'm sorry.
GitHub was there.
That's a good point. So there are now hundreds of contributors for Knative, but these 4 companies or these 4 or 5 companies started the project and actually kicked it off. It was mainly Google driving everything, and then Google instantly open sourced it, and then actually Pivotal Cloud Foundry, they really did a lot of work, and most people from Cloud Foundry brought us to next level, and now of course it's way more companies. So that was mostly about how it started. Now it's evolved to become more thing and with more contributors. But yeah, these were the initial contributors in the project. And that comes even from Knative themselves. So yeah, but I agree. I mean, there are way more companies that now are contributing. That's good. Yeah. It's,
Are there other serverless initiatives like whatever, or people who try to attain the same?
yeah.
Any big players?
So there's Kubeless. Is anyone aware of Kubeless? Some of it, right? Yeah,
exists.
it was. Yeah, it's Kubeless is another initiative that started before Knative, but never really kicked off. But that's the only initiative that tries to bridge still Kubernetes with serverless. There are other serverless frameworks or tools, but they are focusing on just serverless.
I understand.
But for Kubernetes, that's the main thing at the moment. There's nothing else that's promising at least.
Okay. Thank you.
Yeah.
Can it be used to deploy a consumer FAQ so that it's spin up when there's a message in the queue and it's just 0 when queues empty?
Yeah, so the eventing component for now accepts only HTTP requests. So if you have something that brings this kind of type of events, yeah, you will be able to do that. That's just HTTP. Which is most of the requests, right? So
So you have to implement your own event listener, I guess, to trigger that.
there is there's another framework. We thought of actually going into that as well. Keda from Microsoft and Red Hat. It's Kubernetes event-driven application, something like that. And their core idea is we expand the event-driven architecture and applications not only to HTTPS but to any type of format. They will use OpenShift for that, so it's not Knative. still with Istio and stuff like that, but they say, yeah, it's not HTTPS, can be raw format, can be anything, and we can trigger events asynchronous with any type of event. That's SCADA, that's a different way. Otherwise, usually it's just HTTPS, like also here.
Yeah, what's the overhead for scaling down to 0 and when the event comes scaling up? Well,
yeah.
Compared to something that is already running and listening on TCP port and then ready to accept the request, how slower or maybe faster it is.
So that also, of course, depends on the application itself, right? Well, let's take that out of the picture. I'll give you an example. I used a demo from Google that I have it public. It's a microservices demo. It means like 50 microservices. You can play around with it. So I deployed that on Knative. 0, nothing, no traffic coming in. Everything was 0. Then I generated a dummy test that it was simulating requests coming in. First, I started with 1,000 requests per minute. 1,000 requests. Then scaled. It was able to serve all the requests, missed nothing, and it scaled to, I think, 50, 60 containers in less than a minute. Then I did more, 10,000 requests. Then served 95%. It missed a few because it was not that fast. A minute though, and it was like 250 containers. And I did even more and more. So, in a simple application that was provided by Google as a demo, it was able to serve 1,000 requests per minute in just seconds.
Yeah, okay, I mean, but have you ever compared it to a setup with just deployments, where you have a bunch of pods already listening and serving requests? Have you compared to this setup, or did you just play with Google then?
No, I didn't compare it with that setup. I didn't compare it. Not sure if it's well, if the application is still running, it's a pod and it's running. I'm sure it's not that's fast, right? Because then you have to spin up the pod still, and start the pod and the process inside, and then serve. So probably that's slower anyway. But it's in the long run. The idea is that you have 200 of those, but they are not serving all the time.
Save resources.
Save resources, and yeah, have a simpler setup. And that's the idea. That's why it's about serverless. So if it's just an application that should be running like a server, it doesn't make sense.
I think it's more of as you mentioned, designed for development environment. It's perfect use case. Maybe MVPs or like services that you're just starting, you don't know like how they're going to just run them on Knative and console.
Yeah.
Or other way around this.
Yeah.
So, but yeah, perfect use case for development environment, I think.
Yeah, and still it's new, right? So maybe there are more use cases in the future. Maybe it gets evolved into something else, like we found out with Tekton CD. That was a bit unexpected. We're going for QBuild to build up with 2. So
That doesn't need to be 0. It's lower.
sorry?
Lower limit of active.
Like
Anything else? Another question? Or
Are there any customers really using this out besides the developers? Like in production?
in production, no. But Google, they claim that they will be using it in production soon.
TM, trademark.
I can give some insight there.
So not run over prediction.
Yeah, sure.
And it will be native.
So it's not. That's why we also said it's 0.8 version. So yeah, okay. It's just 1 year old now. But it will get there. I mean, we also we will discuss the same thing. If we could find a client case that we could use it, but I think now it's a bit too early. Now it's.
I probably wouldn't recommend it yet.
Yeah, I wouldn't also recommend.
I think,
right?
and it's not only whether it's ready and working as expected. I think it's also the complexity that it brings. It's like everyone who operates it, at least, and who uses that has to know how things work to troubleshoot things, and the edge cases and so forth. So I wouldn't be confident, certainly. But there are people who are.
I can tell you the Google side, but it's gonna sound a bit salesy. If people are interested, they can tell it.
Yeah, go ahead, sure. Yeah.
So from the Google side, what's so interesting about Knative itself is actually Cloud Run. So Cloud Run is the managed version of all this. So Knative, you have like what you did now is you installed Knative yourself and you were messing around with the Knative command line tools and stuff like that, and then you see a whole lot of nitty-gritty details. And then it feels like, okay, this is maybe not production ready yet because you're messing around with a lot of things. if you actually get the managed version, which is Cloud Run, then you just say, okay, I have my application, as a developer, I just have my application, I add a Docker file to it, I say Cloud Run deploy, bam, it's online. So it feels a bit like App Engine, except you can just do anything that you can run in a container, you can just put in Cloud Run. So App Engine, you say, okay, you only have strictly that particular version of Java you can use, or that particular version of Python you can use, or you can use App Engine Flex, which spins up a whole VM, which takes like 10 minutes to deploy sometimes, and takes forever, and it doesn't scale up and down very fast because it's a whole VM. Yeah. And now they came with Cloud Run, which is actually like super tiny things, and you can actually, anything you can put in a container, put it in Cloud Run, deploy, bam, it's running. And that's super simple. It's actually production ready. It's GA. It's also running in Europe now. It used to be only in America, but now you can also say do it in Europe. So as a developer, that's a very nice experience, and it's all built on top of Knative, but you don't really see the whole Knative part. Like all the technical details that we saw now, you don't really see them. And then when it's like that, then you're like, oh, this is actually pretty nice. And then, but then you have these big corporations that say, okay, we're running on Cloud Run, then that's what the developers want, and that's nice, but now we also have these on-prem Kubernetes clusters and all that sort of stuff, and we have our own rules, and we have our own security people, we need to be very much in control. Then you can fall back to Knative, and Knative is then the same experience, but then in your own cluster. But then, yes, you have to do everything yourself, and then you have to manage a whole lot more, and then it starts to feel like, okay, maybe this is not very well documented yet in some places and stuff like that. Yeah. So then it gets a bit more tricky, but the actual managed part is already completely GA.
So does any of those development trickle down to Knative open source, or is it fully proprietary?
Yeah. So the whole thing is, it starts with, same with Kubernetes, right? Like we have GKE and we have Kubernetes. So we started in the Kubernetes open source thing, which is the software that everybody works on. And we have GKE, which is the managed version that Google maintains, and that we do the upgrades for you, and we do all the other things around it. But Kubernetes is still Kubernetes, it's still the open source thing. Same here with Knative. So we have Knative is the open source thing, Cloud Run is the Google managed thing that we handle a whole bunch of things for you.
I even think that they will, in the future, replace App Engine, right?
and does it encapsulate Knative Surf only, or all other ones as well?
All the other ones as well. So it's also
you got like as well.
Yeah. So everything that you do now with Cloud Functions or something like that.
Yeah.
I'm looking at Cloud Functions now, and why the hell would I still use Cloud Functions if you can use Cloud Run? Like with Cloud Functions, you're stuck to a particular version of JavaScript, and you have to write your functions in a specific way. With Cloud Run, you just build a container like you're used to, and you can do whatever you want. And it's still the same eventing stuff that comes in there. So if you get an event from your PubSub or from your Kafka or whatever you get inside, and then you event that and you have a Cloud Run thingy, super easy. Yeah. And that's actually what you want, and you don't want to mess around with all this stuff around. So I'm super excited about it, and I really like where it's going.
Yeah, we as well.
Yeah. And I'm sorry if it sounds too simple.
No worries. Yeah, it's good information. But yeah, we're also excited. We're actually discussing to even go into more in depth in exploring the other components as well, so you might hear more from us in the future. But if there are any more last questions, or we can have some drinks and
take it offline.
Yeah, take it offline too, if you have more.
Yes, thank you for your time. Thanks for coming today in this August day. A lot of people is on vacation. You are also promised a blog post series.
Yeah, we did.
So we will notify you when they will release it, and they also expect to be a series, right?
Yeah, it will be series, so it's just one, right?
So the guys gonna explore these things more and more.
Not to say.
Yeah, no, nothing. I'm not promising. I'm just saying.
We're going to sign up for at least 3 seasons of this. It's coming.
Yes. So thank you again. You can stay here for. I don't say as much as you want, but yeah, we're not limiting you. Just stay for a network. We still have beers left. 1 pizza left. So
okay.
Thank you. And if you can, please put your chair on the chair right to you. You can help us to clean the space. Yes. Thank you.
Thanks.